This video is about refactoring for loops. Now let's look at how we can do that. So for this, I'm going to go into lesson 3, and in lesson 3 I have wonder dot. Okay, so let's set a problem to start the demonstration. Okay, what I want to do is I have a list of string. I'll call it names, and I am going to store in the names of people. So let's say Ram, Hari, and Sham. Okay, pretty easy. And then I have a list of int that will store their ages. Okay, that would be 20, 30, 40. So I don't really care about this. So what I want to do is I want to have an iterator for the index. I is less than names.length, and I keeps on incrementing, and I want to print the names at whatever index you're on. I'm gonna pad right. What this essentially does is it just adds a padding for a pretty print, and then I'm gonna do ages at whatever index you're on. What I also want to do is I want to calculate the total age. The way I do that is I create a variable called total age, make that 0, and then total age would be plus equal the ages at whatever index you're on. Okay, and I'm going to print the total age this way, total age. And for simplicity's sake, I'm also going to add a empty line statement. Now let's start refactoring. Okay, take that away. So I'm going to do dart lesson 3 wonder dart. So when I print that, I see all of the names printed along with their ages, and then also a total age. Okay, now I'm interested in refactoring. So if I look inside my for loop, then what I will see is this line over here is interested in printing the people. Okay, second line over here is interested in calculating total age. See, now when you see stuff like this happening inside a single for loop, you see that printing people is completely different concerns than calculating the total age. Whenever you see this pattern, you know that you can refactor it. The problem is, how do you refactor it? Let's look at that. So I can refactor it this way. I is less less than ages dot length, and I keeps on incrementing. So I am gonna move the calculation of total age into another for loop. Here comes the controversy. Whenever you look at code like this, you will be shocked. Why? Because this actually makes your algorithm worse, right? It takes the computer a long time to execute this. It consumes our memory resources. So why am I doing it this way? So let me tell you something about clean code. See, whenever you hear this term clean code, this is, by the way, a fancy word. But whenever we say clean code, what it actually means is you want to make a code readable for anyone that's going to read your code in the future. And that person can be yourself in the future, or someone else that's going to maintain your code base. Okay. So your primary purpose is to make the code readable. Okay. Now, next thing, I need to tell you a story from history. Okay. For that, we need to go to 1945. So if you look at 1945 and you compare it with today, then you realize that you have a lot of computing resources. So for example, if you take a mobile phone, then you'll realize that a small mobile phone in today's world has more computing power than the entire world in 1945. What that means is we're sitting on the top of a lot of computing power, and also memory, by the way. So if you just compare it with few years back, then you'll realize that 1 GB or like 8 GB pen drive was a lot, and compare it to now, and 8 GB is nothing. Okay, so that's how our computing resources have grown. They are growing exponentially. Okay, so what I want to establish is that we have a lot of computing power in the world. Also, we have a lot of memory. So it is okay to compromise computing power and memory if you can make your code readable. Let me tell you another story. So in the past, we used to code in machine language. Okay, by we I mean programmers. We used to code in machine language. That was zeros and ones. The computer can execute it very quickly, just like that, in an instant. What's the problem with machine code? A human cannot read it, right? And to write machine code, a human will have to do a lot of thinking. Okay, so we created high level languages. High level language allow humans to read code. Okay, but high level languages are slower. For example, Python is very easy to read, Python is very easy to write, but it's slow. Okay, this is known as a trade-off. What we have just done is a trade-off. Okay, we are trading off our computing resources, and in return we are getting readability of code. So this pattern over here, what I've done with these two for loops, is the same. We are compromising our computing power for readability. This is a conflict. Why is this a conflict? Anyone that's doing a CS degree right now will tell you that this is nuts. He'll call you crazy. Why? Because a computer grad is interested in optimizing algorithms. So you're not supposed to do it this way if what you want to do is optimize your algorithms. For example, let's say if Google was building its search algorithm, then Google would not care about readability of the code. Okay, it would be interested in optimization of the code so that it runs faster and the search algorithm is faster. Okay, now we can do it this way because we have a lot of computing resources and we have a lot of memory. Okay, so this will make your code readable, which is why it is okay to compromise computing resources. This is one mindset I want you to have, okay, whenever you are writing clean code. If you want to optimize your code, then it's okay. You don't have to do clean code. You are interested in optimization. Okay, so clean code is only for maximizing readability of the code. Now let's move on. So this for loop over here, what I can do is, am I recording? Yeah. Now the first for loop over here, the concern is printing people. Okay, it's completely different from this other for loop that is interested in calculating the total age. How can we refactor that further? You go back to first principles. What you do is you create functions that can do this. So we can refactor these into functions. Let me show you how that's done. So the first function is to print people. Okay, if what you want is to print people, then this is the code that you require to do it. You are going to require a list of string names and you're going to require a list of integer ages. Okay, so this for loop I can write as print people with name and ages as the parameter or the argument given. Okay, same way we can also do refactor. We can extract a function for calculating the total age. I will do it this way: calculate total. I will give it a list of integer ages. Okay, and I am going to move this for loop over here. I am going to need a variable called total age, that is 0, and I'm going to return total age from here. So I can simply do total age is equals to calculate the total for the ages. So that reads out very well. Okay, what else can we do over here? So if you look at this calculate total function, then the for loop over here is interested in computing the total age. Okay, and there is another way to do it in Dart, and that is known as reduce. Let me tell you how it's done. Int total age is equal to ages dot reduce. The way you're going to reduce it is a and b. A is the accumulator, b is the next element in the iteration, and I'm going to do a plus b. So this will give me a one single number that will be the total age. Okay, and I can return that total age. Now this variable total age over here does not provide me a lot of information. Okay, the reason it does not provide me a lot of information is because the function itself is called calculate total, and the reason we have this function is to calculate the total age. So just having a total age over here does not make a lot of sense. So we can just return this. Okay, so all of these are now gone. Now over here you see that this function calculate total has a single line, and that's a return statement. Whenever that is the case, then this is a pattern. So you don't need to write it this way. In Dart, what you can do is you can write it in a single line. This is known as lambda. This function over here, this what we did over here, using an arrow, is a lambda. Now this looks good. Okay, this code is now looking good. So if the user wanted to look at this code and see what it's doing, then the user can just simply scan through the main statement, and it will realize that this program is for printing people and like printing out the total age. Now over here, this code, we can refactor it further. What is that refactor? You can guess that in the comments below.